Good day everyone, this is the video about our third tool. This is called the automaton creator. Here the students have the task to generate the item sets and the finite state machine of LR states themselves. The widgets are rather similar to the previous ones. Here we can see the finite state machine, which at the moment is just kind of a stub containing two incomplete item sets. We can see the SLR parsing table on the right side, and we can see the grammar and all the previous widgets on the bottom. So here the student's task is to edit this finite state machine. The table will be updated automatically based on what we do here, and if we are ready, then we can start simulation step by step, or just pressing the play button as previously. Here the grammar is changed for this presentation. We switch to a smaller example which allow us to generate words like x times x plus x. And let's start building the automaton and see how it works. So everything should be done here in this editing block. It's very easy to edit the item sets themselves. So for example, here we have the new non-terminal s prime that can be exchanged to s. And because we have .s here, we of course have to include, for example, the item s to .s plus t, and similarly s to .t because of rules 1 and 2. As you could see, when I edit the item sets, I don't need to use these Unicode arrow and dot characters. I can just simply type dash and the greater symbol, and I can just put a period, and it will be converted to these Unicode characters automatically. It's rather comfortable to edit like this. Now, because we have .t here, of course, we will have to include t to .x times t and t to .x as well. When we are finished with editing, we just click outside of the item set, and then it's formatted as we want it. So we have this first starting item set ready. It seems okay. So let's look at this new item set where we move with s. Because we have here this item s to .s plus t, we also have to include another item here, which is s dot plus t. So now that one is correct as well. If you look at a little bit on the right hand side, we can see that here we have the two states that have been defined already. And also we can see in the go-to table that from 0 with s we will go to 10, which is indicated by this arrow here. Because this item set, the state 10, has the item s prime to s dot, which is kind of the rule 0, and the reduction corresponding to rule 0, we have except in the column of the terminating symbol here for state 10. But let us see what kind of symbols can we use to progress from state 0 as well. We can have a progress with the non-terminal t. So for that we need a new state. Creating a new state is simple. Just double click anywhere on this pane, and we will just type in the item where we get to, which is s to t dot, and basically that's it. At this moment this is not connected in any way to state 0. If you want to put an arc here, we just click on state 0 and then click on state 1 then an arc will be inserted, and we can edit the label. In this case, we have to make it to be t. Immediately at this moment, you can see that the follow sets of the non-terminal s were calculated, and the reduction rules corresponding to s to t were inserted into this LR parsing table or SLR parsing table. Also, we can see that from the state 0 with the non-terminal t, we will go to state 1. Okay, what else can we do? We can progress with the terminal x. So let's create a state for that. We can also change the name of the state if we want to. That's allowed. So we can go to t2 x dot star t and t2 x dot. So in this example, as you can see, we have a left recursive rule for s and the right recursive rule for t, just to highlight both of the cases for within the same example. So we want to insert now the arc from state 0 to state 2 with x, and when we do that, you can see that immediately here we can see the shift operation. And also because we have here t to x dot, we will introduce reduce 4 into the follow set of the non-terminal t. So let's go a little bit further on this side. Here we can only move with star, so we can create a new item set for that. So we will have t2 x star dot t, and then we say we move here with the star symbol. From here, the only thing that we can do is to move forward with t, so we will end up with t2 x star t dot, and at this moment you can see that we don't have the reduction operations here, but if we put t here, then we will see 4 in the goto table in the row 3, and also the reduce actions are inserted there. Okay, so let's continue with this state on the top. Here we can also move forward with plus, so we will get to something like s2 s, let's say star instead of plus. Let's make this mistake, t. We actually made already a mistake here at state 3, but let's get back to that later. So we mistakenly changed this plus to this star, but let us assume that we think that what we did was good, and because of dot t, we will include t2 dot x star t and t2 dot x as well. So let's just put that with plus we go from there to there, and we can see that here in the row of state 10, in the case of plus, we don't see the shift operation with 5 to appear, so this is a kind of an indicator that something went wrong. Later on we will have a much clearer indicators for that. So if we go back and see, we can see that, oh, here we made a mistake, so let's change it to plus, and then already it's done there. Now from here we can move forward with t, and then we will get to s2 s plus t dot, and then just add t like that. Now the question is where we will go with x. Well, we can go to t to x dot star t and t to x dot, which is exactly state 2. So we just move from here to here with x, and then the shift operation is inserted there as well. Now we think that we have done everything that we needed to do. So let's try to run this finite state machine and this parsing table on this very simple input. So we start, we shift the X, then we shift the star, and then suddenly everything stops. Here is a clue on the automaton side. We can see that now according to the table, we would go with the rule that's included here, but there is nothing there. We have X and star in the stack. We are in state 3, and the next symbol is X, and we don't know what to do. So the problem is that from this state we should have something with X, but we don't have any arc starting from here with X, so probably we made a mistake here. And that is actually true. Because of this T, we forgot to add the rules with T, so we actually have to put here dot X star T and T dot X. So we are still not done. If we run the parsing again, we will stuck at the same place because we still have to specify where do we get with X from here. Well, again, similarly to this case, we will go back to this one. So from here to here, we will go with X. But now the parse table seems okay, so let's try parsing the whole input. We can do it step by step or just enjoy doing the simulator it automatically, and we can see in both the stack, the table and the finite state machine that things go according to plan, and in the end, when everything is finished, we will just end up in state 10, and the whole input is accepted.